These are potassium spheres. If I throw them into a bucket of water, this happens. And believe it or not, I made them from bananas. The first step is simple. Peel the banana and eat the fruit. Because what we actually need is the peel. The peels must dry for several weeks until they are completely dry. Then we collect a large pot full of them. This can take months, but the time is important so the peels dry fully. Next, we burn them. Pour some alcohol on the material and ignite it with a torch. As it burns, you'll notice a whitish residue left behind. These are ashes mainly composed of metal oxides. Bananas contain a very high concentration of potassium and very little sodium. So we add water and filter the mixture. Magnesium and calcium oxides form insoluble hydroxides, so they stay trapped in the filter. Now we have a solution rich in potassium hydroxide and potassium carbonate. Check the pH, it's close to 14. Next, we bubble carbon dioxide through the solution to convert all the hydroxide into potassium carbonate until the pH drops to about 11. The color you see is caused by organic impurities. So we add activated charcoal and heat the solution to reduce its volume. The next day, we filter it again and obtain a much cleaner solution. Now we simply remove the water by evaporating it in a wide container until it becomes a fine powder. That powder is potassium carbonate. There are still some impurities, but that's okay, because in the next step, the potassium will literally turn into vapor. We will distill the metal and collect it somewhere else in the system. But heating alone isn't enough. We must add metallic magnesium. I mix the reagents and place them in a steel container with an outlet on top. Although potassium is more reactive than magnesium, when the carbonate is heated in its presence, a reaction releases a large amount of energy and forms magnesium oxide. Magnesium acts as a reducing agent, donating electrons and turning potassium into metallic potassium. At high temperatures, potassium becomes volatile, so it vaporizes and then condenses somewhere else in the system. That's why I turn the forge to maximum. Just a few minutes later, we can see liquid potassium dripping into a container filled with mineral oil. When everything finished, I was happy to see a lot of potassium collected. Some of it forms small droplets, so I transfer everything into a beaker and gently heat it to combine the droplets into larger spheres. The oil must be replaced several times to remove as many impurities as possible. Eventually, they become perfect potassium spheres like the ones shown at the beginning. If you cut one open, you can see its bright metallic shine. It's hardly believe this came from banana peels. It almost looks like